Brunel Software Engineering Lab seminar. Sorry, I can hear some. Yeah, if you could mute yourselves, please, while we are on the talk. I'm so excited to have our invited speaker, Dr. Eduardo Guerra, research fellow at the Free University of Bolzan. So Dr. Guerra's research interest has focused a lot on very similar interests that we have at Brunel in the software engineering group. So he has focused a lot on technical debt and architecture solutions and software development processes. And we do see there's a lot of collaboration that we can make between the two groups. So I've invited Dr. Eduardo to give us a presentation about his work, and today he's going to present us how he can use some tools and techniques that he's developed for working in an agile environment and developing and designing a software architecture. So I invite you all to welcome Dr. Eduardo Guerra. Thank you very much.
Thank you a lot for the invitation. It's a pleasure, and I'm excited with this possibility of collaborating with you, and I hope you enjoyed the topic. Today we are going to talk about Agile software architecture practices and just giving you the expectations. I'm going to talk about the practice itself. I'm going to talk a little bit how we get these practices, right? How we obtain them, and I will talk a little bit about them and what are the kind of work that we intend to do on this field, right? So nowadays, we always have like the new thing, right? The new hype, the new kind of architecture, the new kind of technology. And I was, for example, if you want to develop a system with some, for example, I did this slide for some time ago. So now we have new things. These are the things, some of them still there, but there are even new things that I could put there. And sometimes when you are developing this kind of system, if you want, I want to hire something that has experience on this kind of system or on this kind of architecture, you cannot find, because only if you maybe travel to the future and get someone, because everything is so recent that it's really hard to find someone that actually have experience on some of these things, right? And for example, all projects that I was involved, at some times we need to deal with something that, let's say, was new, at least for everybody on our team, right? So some new technology, even some new version, some new platform, some new tool. So we always need to deal with this, right? And for example, of course, there are projects that have architecture. I'm developing a website. There is nothing very different. It's only accessing a database. So for this kind of system, we already have some reference architectures that works well, and we don't need to think about much about our architecture. But actually, that's not the case for most of the systems that we have today, right? So, and when we are working with Agile, or especially when we talk about iterative processes, we have to make this balance, because we want to have a sustainable architecture, in a sense that we want to start with something, we want to go with something that we can sustain for a long time, and because we can make some decisions that will make not viable to continue with that architecture And that's the kind of thing that we call legacy, right? Oh, this is legacy because we can't move forward on this direction. But we also want to start the project as fast as possible, right? We want to start doing the iteration, to start delivering something to the client so we can have feedback. So we need to have this balance, because sometimes to do the first iteration or to start something, start programming something, we need to have at least a little bit of architecture, at least some decisions about the software architecture. But do I need to do all these decisions in the beginning of the project? How we can make this balance, right? And what I see is that today in industry and also on academy, we don't have this consensus on how to do that, how to work with architecture. And of course, we have some, for example, more adaptable approaches, some other things that can help us. But let's say that's not a general set of practices that we can use, right? So I tricked you because I put on the talk title practices, but these practices are actually patterns, right? In a sense that how do I get these practices? Was looking for common recurrent solutions for dealing with software architecture in different projects, in different experience reports, right? And for doing that, I have the help of these two people. One is Joe Yoder. He's known by his work, his paper, Big Ball of Mud, right? He also have a significant work with in adaptive object models. And the other is Rebecca Wifsbrock, that I can say that my favorite object-oriented design book, it's her book. So both of them kind of have a fit on the academy, but they are actually consultants and they do more work in industry, right? So I get I think I consider myself a kind of a hybrid, right? Because I also have experience in real projects, so we get our experience together with some investigation on experience reports, and that's from there that we get this let's say recurrent solutions that we can call patterns, right? For example, Rebecca was, I think, for some time the chair from the experience report from the Agile conference. So she had contacted, she had this wide knowledge about this documented report, and she has a specific interest in software architecture, so we get the go direct on the right ones, right? So let's start. So I will start talking about the practices for that we can do before the first iteration, right? So let's say these patterns are not only to use before the first iteration, but it's like some things that we can do to prepare the team, prepare our software to start, right? And in the next slide, you will see that this presentation counts with some drawings that I made. And I'm sorry, because some of them are not really good, but that's what we have for today. So the first practice I call climbing in the shoulders of giants, because nowadays we have, it's really hard for you to start a project that does not have anything or any solution that is ready to to use, or it's a good start, right? And these references usually help us in solving some problems, usually some problems that are related to what is more common in that kind of architecture. For example, let's imagine that we go with microservices. That's a reference, but we can, let's say, choose more concrete references, like for example, the use of a framework that kinds of already gave us some component structure, or maybe solves problems maybe related to security and transactions. But if, let's say, if our software have some new stuff, we usually have some application specific requirements, and that's, let's say, that's the limit on what we can see when we get in the shoulder of these giants, right? So let's say that the first practice that you need to do when you are, let's say, working with the architecture is choosing your reference, choose your giant. So he will help you to, let's say, to go through the first barriers that you need to face. Usually a reference for some specific kind of architecture or even domain kinds of solves the most common problems that you have there. And then you don't need to, for example, I see, for example, people writing architecture documents and just describing what is already on the reference, what is already is part of the reference. For example, if your reference have an access control solution that it's enough for your application, it's already documented in the reference documentation. You don't need to write it again. But if your application needs something different from this, from what this reference gives to you, no, now we need to do something about it, right? So let's see that for starting our architecture, the first thing is to climb the shoulders of these giants, choosing the right reference that are suitable for the kind of software that we want to develop it. And as I said, we can have, let's say, different kinds of references. We can have more concrete reference, and for example, I think the most concrete kind of, I will turn back in my cool drawing. Yes. And let's say that the most concrete reference that we can have is like this other project, right? So for example, our company or our team already worked on a previous project, and we are going to use the architecture of this project as a reference because, let's say, they share a lot of similarities. So this is, like, I think, the most concrete thing that your team can use. But when you don't have this, you can choose, for example, some well-documented, for example, Java EE. We are going to use Java EE 6. So we already have a lot of books, a lot of APIs, a lot of implementations of these APIs that we can use. So it's something more concrete. We can use, for example, something like Angular with Spring MVC, which is common, and there is a lot of documentation on that, right? Oh, and for maybe for persistent, we are going to use this other thing. So the idea, you don't need to, let's say, have only one giant. You can do like these cartoons when you have one get on the top of the other, right? So you can choose your reference, and they will give you some support, and the idea is to choose things that are ready and to use and already solve a lot of your problems, right? So yeah, to start the architecture, we are going to climb in the shoulders of giants. And then we are going to find where it hurts, right? So we need to see, for example, where in which points our reference it's not enough, or it's uncertain if it solves all our problems, the kind of thing that we need in our architecture, right? So for example, maybe the persistency, it's kind of really heavy, but it works. The transactions are not very, let's say, fast, but they are robust enough. But maybe on the scalability, we have something that it's not actually what we need. Or maybe networking, we need to exchange some kind of information that it's not on our reference, or this is required, needs to get some new kind of knowledge. And an example, in the research institute that I worked in Brazil, we are building a system for monitoring some events that happens on the high atmosphere called sprites. And they have some cool names like elves or things like this. And the thing is, when people are doing these observations, that they have access to several, for you to have an idea, for you to monitor this kind of event, you need to, you are monitoring, for example, something that is happening above some storm that it's like 300 kilometers in front of you. So the idea is that this system has some cameras spread across the country, and we can triangulate to get these events from different perspectives or different angles. And so the people who is observing needs to monitor these cameras, and what we get is like an information system, but we need like video streaming. And let's say that our reference did not have this, but and so in this case we will need a protocol for this that is viable in the network that we have. And that was a problem because many of these cameras were in remote places that does not have high-speed internet. So let's say that networking was a problem that we need to handle. So this practice, find where it hurts, is finding relevant things that you need to handle of your architecture that is not, let's say, included or in your reference, right? So it's the things that you actually need to worry about, right? So, for example, it's you can say, oh, but this is non-functional requirements. It's just but that's a little bit different, because, for example, when you are there in the architecture and you identify your non-functional requirements, some of them might already be solved by your reference, right? So I have some security requirements, but I know that the framework from this reference are enough, right? Oh, we have this problem on scalability. Oh, but my reference, it's my previous project, and it handles the same number of users that we have now. So if we use this, we don't need to worry much about this. So this find where it hurts, it's let's say it's like the challenges. It's finding the challenges for the software architecture that you need to handle in this project. So we start the architecture climbing in the shoulders of giants, but to focus on relevant issues, we are going to find where it hurts, right? And then we go for plan for responsible moments. So I don't know if you already heard this expression, right? But in Agile, we have this thing that, oh, when we should do something, so in the last possible moment, right? So what does it mean? It means that I need to, let's say, prioritize what is more important and things that are not so if I can do this later, it's because it's not important enough. So I should be doing something that has a high priority. So that's this expression that I should do things in the last possible moment. But for architecture, people say no. Sometimes if you do things in the last possible moment for architecture, might be too late, and you might not know if it's too late or not. So people say you must do things in the most responsible moments, right? So the architecture, things on architecture, you should handle in the most responsible moment. But we know that sometimes if it's hard to know when it's the most responsible moment, right? It's like when people are driving the car and you should keep a distance, right? From the car that's in front of you. So it's like when the car in front of you brakes, if you don't have the distance, like the last responsible moment was already passed, right? So this practice is about plan for this responsible moment. So the idea is to, for each of the things that hurts, right? That we find, that we think that are relevant, we are going to make a plan on how we are going to handle these issues, right? And I think that's what is different here from what we do in the let's say more traditional architectural approach, is that we don't need to have an answer right now. We don't need to have a solution right now. So a more traditional approach would be like, oh, we have this issue. Let's solve this in the beginning of the project. Let's solve it right away because it's an important issue, right? So here we don't need to actually handle all of this, right? So imagine this drawing that have this map in which we are searching for the application architecture, right? And for example, we have a security that we can go to single sign-on for independent authentication. I might leave the boat without knowing which path I'm going to do, right? But I need there is some place I need to know when I need to make this decision, right? For example, for the scalability, I might want a cloud solution or a server cluster. And if I want to be able to make this solution not in the beginning of the project, maybe I need to take care of some things or be careful about some things, right? In a sense that I can choose it later, right? So I don't just leave it for the most responsible moment. I plan, I prepare myself to make this decision later, and also to know when I need to make this decision, right? And I like to talk about this monster in the island, right? Because if I know that there is this possibility to have a monster in the island, imagine that is the name of this monster is performance. That may be a problem, but maybe I will find my architecture without finding the monster. I'm not even sure. Maybe this monster it's only a legend, and I will not find this monster. And one approach is let's hunt the monster. So I can, let's say, lose my focus on finding the architecture, right? And just go after the monster. So I might easily lose focus, right? But in the other hand, I don't want to ignore the monster, so it can come there when I'm camping at night and just destroy everyone, right? So I want, for example, to be prepared for this monster. I don't need to hunt this monster, but I want to put some people watching, maybe observing during the night if something wrong is happening, maybe have a escape plan, or maybe at least bring with me some weapons that can protect me from this monster if he attacks me, right? So the idea is, for example, for the performance, I'm going to prepare myself to see if it's going to be a problem or not, right? And have some way to know if when it's the time to handle it. For example, for this mounting, for this scalability mounting, I might know that at some point I will need to choose. But for example, for the monster, I might not know exactly when I need to handle this monster, or if I need to handle this monster, but I'm going to prepare for this, right? So after finding where it hurts, I'm going to be prepared for handling the most critical issues by making what I like to call technical plans for being prepared to what I can find on my way, on my quest for my system architecture, right? Tracer bullets. I will consider that most of you already played this Angry Birds game, right? So what we did when we played the Angry Birds, we reach a level, we just throw the first bird to see where it reaches. If it gets on the target, so I might know if I need to go a little bit higher or a little bit lower, or if I need more strength, if I need less strength, something like this, right? So the idea of tracer bullets are like this. So we are going to pick up a simple feature to know if our architecture is it's solving it well, right? And I also like to mention that it's in the tracer bullets where we do, let's say, the low level, the code level architecture, because it's very beautiful to say, oh, let's use this library with this database, with this thing, but in practice, they don't integrate well, right? So who already participated in some development probably already go through, oh, this JavaScript library doesn't work well with the chart library that we want to use, or this version is not compatible with that. And this is what I call like the low level, because when we are thinking about the components, everything is like the paper accepts anything, right? But we can, let's say, we can draw arrows and boxes, and we can point where we want. But when we are actually implementing, there are some low-level problems, because these low-level problems, if we just let the architecture is ready on the paper, let's start the first iteration to start it creating features. And then they find this problem, and the first iteration, it's a disaster, because they find some problems, they are not able to deliver the first features because they spend a lot of time with this, and the morale of the team goes down. And it's good to know that we have time for this. And this low-level architecture, I think it's also really, really important to, let's say, let's look in the code to see how it's how it looks like. So I already, for example, we planned, for example, a layered architecture for a system. And when we did the tracer bullet, we saw that there was a layer that was useless, right? So they are not having any important responsibility. So in the end, it was like we throw the bird too much higher, and it was like an over design from our part. But in the other hand, we might find out, for example, that what we are doing are not enough for the requirements, right? So, oh, this JavaScript library that we are trying are too slow for what we are looking for, or this is not integrating well. So maybe we need to rethink some things that we are going to use there, right? And when I talk about a simple feature, it's like I'd like to call it an architecturally significant feature. And a good thing about tracer bullets is anytime that you have something new on your architecture, you might create a tracer bullet, which is, let's say, a task that someone is going to do to explore how they are going to integrate that new thing on their architecture. And after being created, this tracer bullet became a reference for the other developers. So who creates the tracer bullets are not actually, let's say, just experimenting the architecture, but this is, for example, we are going for this kind of feature, we are going to have a controller, this is how the persistence is going to work, we have this factor, we are going to use this pattern, this is a proxy, and this is how things work. And all functionalities are going to use this tracer bullet as the reference. Like when you find the right angle for the bird, then you keep throwing them, the other ones on the same direction, right? So it's the same thing when we got right our feature, right? So we get, now we find something that works well for this feature. So let's replicate, so let's use the same structure for the next ones. And imagine that, for example, but now in this iteration we are for the first time creating some asynchronous processing for this. That's the first feature with this asynchronous processing. And let's do a tracer bullet to let's say create an example of how all what's going to be the structure for all asynchronous processing features, all features that use this same thing, right? So when you are assigning the task of doing a tracer bullet, it's not like the same kind of estimative that you need to do, because you are not only creating a feature, you are creating a reference. So you need sometimes to explore different solutions to see how it works, maybe do some refactoring and see what would be the best way to create that kind of feature on your system. So when we have this, when we climb on the shoulders of giants and we choose our reference, one way to define this low-level architecture to see if all our giants are working well together, we do a tracer bullet. And also, the tracer bullets can guide the choice for planning for this responsible moment. So, for example, if you have something that you want to do in the, you want to validate in the beginning, or this kind of tool or this kind of server, it's enough for us. You can do a tracer bullet where you explore this a little bit, and then that can be, for example, a first step for creating your technical plan for handling something, right? And even one of your plans might be include a tracer bullet for solving some issues right in the beginning of the project, maybe because it's something critical or something that can be really hard to change later. And we need something similar for testing, right? And I think that nowadays I don't need to argue how important testing and more specifically automated testing is. But what I see happening is it's like test this, and we have all this structure for the architecture, and this is this that you need for creating this feature, you need these kinds of components. So you have everything there for the component, but for testing, now for testing I need to take everything from my head, and maybe things that are already see happening, like in the same team, two developers doing the same structure for the architecture, but using completely different approaches for testing. One, for example, for testing the controller, it mocks the business class. The other one tests everything together, and then it's really hard for you to reuse or to, for example, if you need to refactor something, so each one is in a different way. And even for, let's say, the more hard kind of testing, more hard type of testing, when you need to test, for example, some feature maybe that have some parallel processing or something that's more hard to test, it might be harder for a more junior developer to know how to make that test. So the idea of the test architecture is to, let's say, for each component or kind of component on your architecture, you will have some way of testing it. So it's like the architecture that you are going to use for test code, right? It's not like that, but kind of, right? So for example, you have a persistence, a class that takes care of the interface, persistent interface, right? So how we test this? We are going to start with some pre-loaded data, or we are going to start from zero. We are going to use some framework, how we are going to compare with things in the database. So the idea is to, as we define the architecture on the one side, we are going to define how we should test each component of the architecture on the other side, right? And again, this will be like a tracer bullet for testing, right? So this is how we test every component on the architecture. And it's okay, for example, if you have some kind of component that has, for example, manual testing, right? And as an example, this project that I mentioned to you, that we monitor these events on phenomena on the atmosphere, we need to deal with this pan tilt, which is something that turns the camera from one and other side. And what we decided to do is that we created a code that is specifically for moving this, right? And this specific class, we do some manual testing. So we go there and we do the manual testing, and we see if the pan tilt is moving for in the right position, right? But because it has this physical component that makes really hard to see if it's actually moving, right? But for all other classes that use this one, we decided in our test architecture that we are going to mock this class. So we defined the approach. Maybe if some junior developer gets there, oh, how am I going to test this? Now we have document and defined. We have a reference, so we actually have some code that did this, and uh, um, he can use to see. Oh, let's see how do I test this kind of thing. Right? And of course, there are some other kinds of tests that are not the functional kind of tests that we need to define what kinds of tests we want to do, how frequent we want to run them. So for example, imagine that we want some usability test. It's some kind of test that's hard to automate. So how frequent we are going to run this, right? What's going to be the approach? What tool we are going to use? Right? So this is like the test architecture. So we decide how we are going to test each component on the architecture, right? So when we decide to climb in the shoulders of giants, right, we also want to define how the tests are going to be created. And for this, we use this test architecture, right? And we can use the tracer bullet to validate the test architecture and also the test architecture to validate our tracer bullet, more specifically if it's testable, right? So usually this is kind of, I put as separate practices, but let's say in practice, we do this together, right? So when we are defining the tracer bullet, so how we are going to implement something, we also define how we are going to test the kind of component that we are defining on the tracer bullet, right? And let's say if this structure is not testable, maybe I need to refactor something so I can, let's say, it make viable my test architecture, right? So I mentioned that these practices are to do in the beginning of the project, and as you can see, none of them takes much time, right? So you are going to define your references, you are going to identify the points that hurt, that your reference is not enough, that you are going to do something, you are going to make plans on how you are going to handle them. You don't need to handle them, all of them in the beginning, and you are going to pick up at least one functionality as a reference and define how you are going to this low-level architecture, how things are going to work in practice, and how you are going to test them. So none of these are take much time, right? But what I'm want to say is that you don't need to use only this on the beginning, because for example, maybe you are let's pick up the same example that now I need a feature that I'm going to start using some asynchronous processing, right? So I might choose a reference for that. I might find some new things that hurts. I might need to make a plan for them. I might need a new tracer bullet and I need to increment my test architecture for how I'm going to test the components of this new thing, right? So all these practices, I think, are important to be done in the beginning of the project, but they are not exclusive for the beginning of the project. I participated at projects right in the middle of the project. Oh, that's something new. Let's do a tracer bullet. Let's increment our test architecture. Let's now talk about things during the project, right? So the first thing is the architecture in the backlog, right? So I think this might look so obvious, but actually for many people in industry, it's not, because you ask them, how do you plan your architectural tasks. And some of them say, oh, it's in the middle of the functionality, or like they are hiding this from their clients, right? And so it takes time, right? And if it takes time, it needs to be planned. And I mentioned here backlog, but it's let's say it's not necessarily you need to use have a sprint backlog, or you can use other methods. But what is important is to plan this uh, um, these tasks or these activities that are related to the architecture. You need to put them, you need to estimate them. For example, creating a new tracer bullet is an example, right? When you need to put things in the backlog. Some approaches that I already saw working well. One of them, for example, when you're, let's say, when you have a client that sometimes have some kind of technical background, or you have a client that actually listen to the developers, what developers are saying, and can handle this prioritization of functional stuff with architectural stuff being implemented. You can put everything together and making your plans, right? Already see things like, oh, we have an important delivery, so let's have less things about architecture this week, and in the next week we can put all these things, or in the next iteration we can plan this. So I already see this working really well, but sometimes uh, um, when your client are, no, that's my stuff, I don't want you doing security, my stuff, it's more important. Sometimes it's good for you to have like a separate backlog or a separate planning, and you have, for example, some hours, let's say, that are not for your client to prioritize. It's for your technical team to see what can be done, what is the priority for only for the architectural tasks. So this way, let's say, usually when the client understand the importance of the architecture, but he also recognizes that for him it's hard uh, um, to mix this with what he actually needs in terms of functional things in his software. So it's like, okay, I don't want to prioritize this, but I will give you some hours to handle this. I think the worst case is when you need to hide things from the architecture in the middle of functionality. But I think that what is more important is that you need to put it on the backlog, you need to plan it, and I already see like some important things on the architecture, like starving, right? So there's never time to do, that's always more important things. And when you see like this more responsible moment already passed. Okay, so to
Mark, are you we're already at the end, so can you conclude?
Okay.
Martin? Yeah.
I already have some practice, but I can go fast through them. Sorry for that. I lose the notion of time. Okay. We have this architectural trigger, which is something that you can put on your technical plan. It's something that, for example, it's how you handle the monster, right? So how you can know when you need to do something, when some architectural work needs to be done. So usually you put some metric or put something that can give you this direction or on when and how you need to do this. So this is something that you can put on your plan to make it, to see if you need to do it later and what is the right time. So this plan can include this architectural trigger. We have the architectural spikes. Usually it's when you don't have a clue on how you are going to do some task. You reserve some time, and what is important on these architectural spikes are it has a very well-defined goal, and it also have this it has a fixed time box. You cannot pass this time during this iteration. Because if you let me, I like to research things, I like technical stuff, I can stay forever researching cool things from the architecture. So we need to have this, like I like to put, what is the question that you need to answer in this spike, right? And what's the time you have for this? And then on the retrospectives, the developer can report this, and sometimes they need another spike and another spike. And for example, when you have some a sequence of spikes that you can solve the problem, maybe you should hire a consultant or try something, put all the teams on these, get someone from I don't know, but if you do some you have many spikes and you cannot find a solution, maybe it's time to like stop the line and see what we can do. You can also include these spikes in your plan, and both the spikes and the architectural triggers are going to add tasks for the backlog. So if some architectural trigger actually triggers something, you need to you can add some tasks, but not necessarily they will be automatically be done at that time. You might need to get into planning to be prioritized as everything else. Technical debt management, I won't talk much about. I think most of you already know, but it's important, especially for managing the things, the biggest issues on your architecture. I usually have let's say, the most wanted technical debt, right? So we do a top 5 on the technical debt, and we always consider them during the planning. So to be aware of the problems in the architecture, you do this technical debt, and this can also add tasks in the architectural backlog. And finally, it's the last, the continuous inspection. I can talk a lot about this, but I will let this maybe for some questions or for some, maybe for another talk about some a lean approach that I'm also developing about software analytics, right? But how it integrates, so it can help to detect problems in the code and in the architecture, and the technical debt management can use this continuous inspection, and the architectural triggers can be part of this continuous inspection, right? So these are the practices. Sorry for getting out of time. And the idea of having this is it's an approach that you can manage these architectural risks, having this sustainable architecture, and not having, let's say, starting the project as fast as possible, not let's say sometimes you cannot, it's not viable to start right away or start really fast, but evaluating this, we are going to start as fast as possible.
Thank you. So, yeah. So I think I'm going to open the room for questions right now. So by the way, thank you, Eduardo, for giving us a full picture of the whole Agile process and how to incorporate architecture in it. I think it was really a full overview. So does anyone have any questions? There were, I suppose, many of you are reflecting on the talk, but feel free just to raise your hand and as well unmute yourself if you have any questions.
Or maybe send on the send on the chat. By the way, thanks a lot, Ashley.
Many thanks. So maybe while people are thinking about questions, I had lots of questions actually. Okay, there's hands raised actually right now. Great. I'll give priority to. So I think James has your hand up. You're muted. Yeah.
No, I always have this difficulty thinking about changing architectures and like how much is the cost when you want to change something. So I found interesting what you said about avoiding the monsters and delaying your choices. I was thinking if you have some more advice on this problem of like you decided on an architecture and then you notice, wow, you have to change something and it's very costly then to change it. If you had some, I don't know, some experience on a trick or something.
Yeah, I think you touched the main point, which is the cost, right? So what is, let's say, what is cheaper? Maybe to implement something more sophisticated in the beginning of the project, and let's say maybe maybe not using it, or maybe it's being some over design or adding some weight in the architecture, or maybe delaying it. And I like to say that sometimes we have like some clever solutions that we can, for example, leaving an extension point, which is something that does not have, let's say, it's not expensive to leave there, or leaving some spot where we can include this later. But if you don't think about it in the beginning, maybe you won't leave this spot. And that's why we need this plan. So let's say that this plan it's much more, it's a lot about managing risks, right? So you should see what is, if the risk is too high, maybe let's do in the beginning. Maybe you don't, it's not much risk. We can leave a little bit for later. And we can risk a future refactoring, or we can make our let's say our solution more flexible to be able to have this in the future. Maybe we can do some, for example, some experimentation or some controlled experiment, for example, to verifying the performance of different libraries. But for example, if I isolate this library in a sense, in a way that is not hard to change it later, maybe I don't need to do this experiment right now. I might see how it works in production and maybe doing some like live experiment. So it always about the cost and how important it is. My main advice is you might not have the solution, but you need to be aware of your problems from the beginning. I answer?
It's a complicated topic.
Yeah, sure. Yeah. But and of course, there is not an answer that will fit all cases. As I'd like to say, my friend Joe Yoder that I mentioned, he always say, "Oh, I'm a consultant," and as a consultant, I will always ask, I will always answer, "It depends."
Mohammed, you had your hand raised. Would you?
Yeah, probably similar point to what's been asked before. It's always a balance between how far do you go in the beginning. And as you mentioned, probably it depends on situation. But what interested going forward, it's in two scenarios, either before you start or going forward after you start in kind of advanced sprints. How much do you think you need to keep percentage-wise to keep an eye on either technical depth or solution architect based on new feature or continuous development? So it's more about how much do you keep it from, kind of a point or story points or capacity point of view. And do you see that usually, is it like independent resource to keep an eye, or is part of the development team?
Yeah, it's I think it's something that when you start the project, you might let's see how many points you need to handle the architecture, how many of them are high priority, right? And how many you can leave a little bit for later, but not too late too. So the idea is, let's say, start with some percentage. Usually I put 30%, something like this, 20, 30%. And then in the, let's say, in the retrospectives, you keep seeing how, let's say, how fast is your let's say this architecture backlog are being handled, and if we need to go, if we can go slower and give more room for the actual functionality, or if we need to we need more time to handle these things. And of course, there is always this negotiation, iteration by iteration, like, oh, we have this feature that's really important, so let's pick up some of the time for the architecture, or we have this architectural issue that is critical, we need to do it right now, and we need some time from the functionality. There is always this thing, but by my experience, it's around 30 to 20% of the development time. And of course, it depends on the kind of the projects, on the kind of challenges that you are facing.
That's perfect. Thank you very much.
Okay.
Maybe right now, just after Mohammed's question, actually, I wanted just to follow up in the sense, what's the importance of having a software architect actually present in all these team meetings? And for the idea of, because there are organizations that sometimes remove the role of an architect as a central role, whereas having an architect attending the sprint planning meetings or the retrospective meetings, who can always inspect or give a vision about the implications of all the features that are chosen, or the costs in every iteration. So maybe you could give us like a perspective on that.
Okay, this thing about having an explicit someone with the let's say software architecture written below his name, right? I already saw that working, and I already see some things working well without it. And in a sense that, for example, a team that have usually have some, let's say, at least half of the developers are more senior, and let's say take care of this together. So they have this shared responsibility for this. One thing that let's say that might happen when you explicitly have a software architect, is to have this kind of thing that it's not my responsibility, right? For other people. Oh no, that's the software architect. And I think that let's say a software architect should be, let's say, who mediates or who worries about it, but it's everyone's responsibility. And this is everyone should participate on architectural tasks. For example, one thing that I like to do is, for example, when I talk about the tracer bullet, for example, when we are doing the tracer bullet, I pick up, for example, the junior developer and say, you are going to be responsible for the controller. And that is something like it's trivial and it's like ready to use from the framework we are using, but he feels like responsible for part of the architecture, right? Oh, and you need to do this really well because everyone is going to use your code as reference later. And that makes him feel responsible. So I think it's important to everyone be involved in some level in this, let's say, the junior a developer is not capable of making decisions, but it's capable of participating on some activities so he can feel that he's also responsible for the architecture. And about the meetings, in a project, we reached a conclusion that we need like something like a technical a retrospective, something like this, where we have things like taking a look in the technical debt, discussing the spikes, taking a look at the continuous inspections tools to see if there is something critical there, to review our plans, and to see how we evolved on our plan, right? So if we do some task that was in this plan, how we are, if we conclude or if it's something that we need to do. So for example, imagine that as part of a plan, I need to implement some collection of metrics. So in this, let's say, it's not like a retrospective, but it's more like a technical meeting where we discuss technical things and technical important decisions. And I like to make it separate because sometimes the client is not interested on that, or in the let's say in the retrospective that's for everybody, there might be people that are not interested on that, and we are, let's say, using the time of these people for something that they don't care, right? So that's why we kind of separated. I kind of answered.
Yes, thank you. Another aspect that I'm interested in is you've talked about initiating a new project, okay, and defining your reference architecture. Maybe could you discuss about as well, because most organizations that already exist already have their legacy systems, and the problem is, okay, they haven't updated their architecture, or their architecture hasn't been able to evolve anymore. So definitely they want to migrate their architecture. So how do these patterns that you described actually can be applied in these kinds of projects, where you actually have an existing one, but have an existing architecture. However, you don't want to repeat the same issues that you had in the previous architecture in the new migration?
Okay, in these cases, I always start with the technical debt, right? So let's see what is the worst. What is what we need to be handled, and usually in this kind of case that we have like an old architecture that needs something, we will have some huge these huge problems, and we started doing this technical plan for them, right? And then, or refactoring something. Sometimes we decided to fix what we already have. So for example, we can, in this sense, use the tracer bullet for let's say to define the new way of doing something, or for establishing that something, how something need to be done. Another thing that I think it's usually a big problem in this kind of system is testing. So this lack of tests is usually a big problem, and it's another point that, for example, if you want to start any refactoring, you need testing. And sometimes in this kind of old architecture, there are some solutions that are not testable or have low testability. So the first thing is to create this, let's say, I said many first things, right? But usually one of the let's say, the first concrete actions are to create this test architecture. So how do we test this bad architecture? So at least creating some tests there. Usually these tests are really big, right? So there was a company that has this annual tax thing that was like a lot of entangled code. Really, I was talking about testing and something. I swear to you, the developer talking about this almost cried in front of me. Oh, I find this variable and I was 2 hours to find that it depends on 2 other variables that I don't know either. Right? So he almost cried. And what I say is like, okay, how we test this, because it's too messy. So what we did was like, we pick up some real let's say some real case of them. It was a lot of data. It's something that take, I think, almost 2 hours to execute. And he ran this thing, and the result was in the database. So we pick up a domain expert. He reviewed all this, all the results to make sure that it's correct. And like we froze this, right? Oh, if it's the same thing, we will have always this input and this output. And after creating this, we start refactoring. So, that was like the test architecture that we can do right now. And after we starting to decouple things, some calculations, they start doing some unit testing there, and then we start to structure a better test architecture.
Okay.
So basically, detect the problems with the technical debt management, and usually starts with the test, improving the testing.
Okay. So thank you very much. And actually, it was one of the first presentations about architecture that were so animated. So I have to commend you on that. So thank you very much for your talk. So if anyone wants to have a chat with Eduardo, I think you can contact him, and I'll see you next time. I think we have another talk next week as part of the digital Set Digital seminar. So hope to see you there next Wednesday.
Okay.